Hey folks, Dr. White here, just having some fun with the simulation software from the PhET website. That's P-H-E-T. I really like this simulation because it does a great job of showing an equilibrium process. The equilibrium process here specifically is bouncy balls, and these bouncy balls can stay on either the left side or the right side, and they can also bounce over this little hump here in the middle. And it's a really good simple application of an equilibrium process. So what I'm going to do is just start off here. I'm going to raise up the level of this A platform here. I'm going to start off, I'm going to put 100 particles on the side, the left side here. And you can see the bouncy balls bouncing around. And you can also see that some of the bouncy balls are jumping over to the right hand side. And if we keep a count of the bouncy balls, you can't see it on the screen, but over here on the right hand side we've got a count, and right now we've got about 65 of the green and then 35 of the red. So after a while we let this system hit its equilibrium point, which means that you hit a point where the number of green balls is going to stay more or less constant, and the number of red balls will stay more or less constant. And they stay constant because the rate at which green turns into red and at which red turns into green, the rates are equal, which means if you think about the number of green balls, as you lose one green ball and it turns into a red ball, you're going to create one green ball from a red ball going the opposite way at the same time. So that's why the numbers of balls stay more or less constant. Now, hopefully you can see it here in this video, but I encourage you to actually go and play with the simulation yourself. If you look down in the description for this video, I've got a link to the PhET website, and you can actually click on it and open up this simulation and just play around with the number of balls, play around with the level, the size of the hump. You can tweak a bunch of interesting things. So don't take my word for it. Play with it yourself. Thanks.